For this Friday, we'll be using the lecture time as a review. I'll probably just do some exercises on adventofcode.com. And then, if you want to use that time to actually do the midterm, it's up to you. I'll tell you right now, there are two exercises. It covers file I/O and strings. One of them, what you have to do one of them in C, you have to do one of them in Java. Whichever one you choose, it's up to you. So that's how it is. Kevin last night, our LA, went through it, and he said it took him about 45. It actually took him an hour and a half for both of them, for all four programs. So that's about what you can expect. Probably a little bit less than that. Any questions in the midterm? Or not midterm, but exam 2, right? 50 points. No? All right, so then today we're going to finish up on encapsulation. Encapsulation being, of course, structures in the context of C and classes in the context of Java. We kind of finished up with everything that I wanted to do in Java, but there's one last piece of the puzzle that I want to cover here. Remember that, just to walk you through what we were doing, remember that we loaded up all this book data. We had defined a book class containing the author, title, release date, rating. We have defined an author class, which is the first name, last name, and date of birth. And remember that we didn't bother with the date class because that was already built into the Java time library. And then what we did is we took all that functionality that we had written before and put it into a load from file method. We wrote another method here, get the highest rated book, another method, get the lowest rated book, and then another method here, get Frank's books. Right? So what I want to do now is I want to generalize this. I want to get books by author. Right? I don't want to just look for Frank Herbert books. Right? I want to look for all books by a certain author. And what I'm going to do over here is I'm going to create that author. A is equal to new author, Frank Herbert. There we go. And I don't know if I'm required to, I'm not required to provide the date of birth because we didn't have that data. And I'm going to pass that in as another argument here so that I'm generalizing it. So I don't have to rewrite this function for Octavia Butler or Terry Pratchett or some other author, right? So author A. So how does that change everything over here, right? Well, I'm going to check the author, their last name, and if it equals the author that I've been given's last name, a.author, a.get last name, there we go, and a.get first name. If both of those books match, then I'm going to go ahead and add it to the list of books here, and it's probably more appropriate to call this author books, right? There we go. Author books and author books, not just Frank's books. That's a little bit better, a step in the right direction, right? Oh, what are you complaining about? Did anybody see what I did wrong? Oh, there's an extra dot there. There we go. Okay. So that's a little bit better step in the right direction because it's more general, right? Well, wait a second. This seems like a lot of code. I mean, checking to see if a last name exists and a first name exists. I mean, what you're doing is you're asking a question about authors, right? And so when you have functionality that acts on the author's data, like a last name and first name, where does it belong? So remember what encapsulation is. It's the grouping of pieces of data that act together in one logical unit. Both languages support that. It's the protection of that data from the outside world, right? So I've got getters and setters here. Right? But 3, it's the grouping of functionality that acts on that data. I've got functionality here that I've got a book's author and another author, and I want to know, are they the same person? Right? That sounds like a question relating to author data, their first name and last name. So the question is, does it belong here in my demo class, or does it belong somewhere else? Where should I put it then instead? Where? In the author class, right? It acts on the author's data, so it belongs over here in the author class. And I'm not even going to write it. Instead, I'm going to go ahead and generate it. Right? Hash code and equals. Don't worry about the hash code for now. I'm going to generate an equals method that given this author and this author, are they the same author based on the first name and the last name? That's why these are checked. If you want it based on different state, then you like a unique identifier, like a social security number or something like that, or an author ID in your database, right? Then you would make it based on that piece of data. Right now, I'm just going to make it based on the first name and the last name. So lots of complex code here, right? That's why I didn't write it, right? But it's basically doing a bunch of corner case checks, right? I've been given this object here, and is it equal to this object, right? So there's that other object, and if the first name is null and the other's first name is not null, then of course they're not equal. Otherwise, if the first name is not equal to the other's first name, then we return false. Otherwise, likewise for the last name. If one is null and the other is not null, then it returns false. Otherwise, if if the last name and the last name are equal to each other, then we return not equal to each other, then we return false. Otherwise, if you after all of these checks, right, if everything checks out and they have the same first name and the same last name, return true. They're finally true. Okay? And I am glad I didn't have to write all that out, because I would have missed one of those corner cases, or I would have missed the logic or something like that. Instead, all I had to do was edit, generate the equals in the hash code method. So now let me come over here to the demo class here, and let me get rid of all that. If b.getAuthor.equals, right, A. If that's the author that you're looking for, then go ahead and add that book. See, much, much better, right? Right? Because now, before the code that I had, it wasn't actually checking to see if the first name was missing, if it was null. But now I'm encapsulating all that complex logic over here into one function in the class that it belongs to. That's good encapsulation. Right? I'm putting things where they belong, right? Organizing code. Author stuff belongs in the author class. Book stuff belongs in the book class, right? Student stuff belongs in the student class. RSS stuff belongs in the RSS class if you chose to do the Java version of that. Okay? All right, I will go ahead and post this code later because that's all I wanted to do, right? Now it's perfect. Not perfect, but good enough, right? Just like as we say in engineering, what's better than good? No? Good enough? All right. We're done. All right, I want to do the same thing that we did on Wednesday, all right, putting all that into other functionality and finishing up with these three reports, and let's go ahead and repeat it over here in C. Now remember, what I started to do here before we switched over to Java is I wanted to create an entire array of books, okay? Well, immediately I'm starting to think, well, wait a second, this is a lot of code, right? I probably should put that into another function, just like I did over here in Java, right? I have a load from file function. Let's do the same thing over here. Let's go ahead and create a function to return a bunch of books, right? Load from CSV file, right? Const char star file name. There we go. And what would it look like here, okay? Let's go ahead and start writing this function because we may need to have some other considerations, okay? I'm going to go ahead and take all of this code that opens the file, processes it, right? Closes the file, and I'm going to bring it over here to that function. Now, obviously, we're not going to use all of this. For example, that's a comment. That code is self-documenting right there. That was cruft. I'm getting rid of it. Right? Here's my file name. I'm not always going to open books.csv. Instead, you give me the file name that you want to open, and I'll do it for you. Right? Read it line by line. Let's get the first line. Right? That first line is cheating. Right? That is telling you how many elements are in the first line so that you don't have to guess. Right? Sorry about that. Usually it's a dreary day, or it started out as dreary, but now it's not. This is part of the other report. I'm not going to include that over here. Okay. Num records, however many bytes a book takes, I'll go ahead and create my library, and remember to return it down here. Return library. There we go. What else can we get rid of on this? Well, I'll go ahead and leave this cruft in here just so that when I post the code, you understand what it's doing. But otherwise, I create a book. Great. Oh, you know what? And then along the way, I don't need this stuff. I don't need to print it out. There we go. All right. Create a book from the above data. Now let's think about this really quickly, especially since now this is completely different from Java. We have memory management concerns here, right? So how am I going to put this into my library? I want actually the ith book library, sub I, to be equal to whatever book is created here. But that's not going to work. Library of I is a regular old structure. Book B is a pointer to a book. Right? I could do something like this. I could dereference it and then copy it into there. That's going to lead to a memory leak. To understand that, I would encourage you to take this and put it into Python Tutor and see it working. Okay? But instead, what I'm going to do is I'm going to look at this from another angle. Remember over here how we described the create book. This is a factory function that creates a new instance of a book. What does it look like? It's up here. We initialize it by calling malloc. All right? Now, tell me, do we need to create that book here? The entire library has already been allocated for us. Right? In other words, this book already exists. We don't need to create another one, copy that over, and then leak this memory over here. So what I want to do is I want to go back and rethink this. I do sometimes want to create a book, but sometimes I already have a book created, in which case I don't need to return it. Void. There we go. Book star B. So now this is not creating a book. A book already exists. What it's going to do is something very similar to if you did the C version yesterday, it's going to be initializing that book. This book already exists, but it's title, author name, first name, last name, whatever, right? They haven't been initialized. So we'll initialize those for you if the book already exists. Right? Why am I not putting const here? Because I'm going to be making changes to it. Right? So let's go ahead and get rid of that. And this is not going to be that bad, right? Why? I pretty much have all the code right here, right? If the book already exists, then the only difference between these two functions is I don't create it and I don't return it, right? So all I need to do is take all of this and copy and paste it, and I'm done. Right? Anytime you find yourself copy and pasting, though, that should be a really big red flag, right? Should I copy and paste those 10 or 20 dozen lines of code there? Repeat that code, repeat that code. Remember the DRY principle. Do not repeat yourself. Which one of these functions could call the other one? Create book does more than just initialize book. It creates the book, and then it returns it. But all this stuff is all repeated code right here. Right? Get rid of it. Init book, B, title, author, first name, author, last name, release year, and rating. There. Right? It's not just about reducing the number of lines of code. It's also about reducing failure points or potential failure points. Right? What if in my copy pasta, fugue, I accidentally, missed something? I didn't change something properly, right? Now that same bug is in two different places. Great, bug report comes in. I go and fix it, right? But the other one that was copy pasted, nobody knows about that bug until much later, and then it manifests it again. I fixed this bug before. No, it's because you repeated that code over there, right? It's about reducing failure points, right? And so you don't want to repeat yourself too much. Right? There are times when you can go ahead and go against that principle, but generally that's a good principle to follow. All right, now back down to here. I'm not going to create the book, right? It's already been created up here, right, in this library. Instead, I'm going to initialize the ith book, okay? And to do that, I'm going to call init book on library sub I. Now tell me, when I compile this is going to be at least a warning, if not an error, what is wrong with that piece of code right there? gcc c wall book.c. There you go. It's complaining about this right here. Right? Incompatible type of argument int book. Right? I expected a book star, but I got a book. I expected a pointer to a structure, but I got a regular old structure. Right? Remember, what is library? Library is a structure pointer, a book star. So when I go library sub I, right, is a single structure, a regular old structure, a book. Right? So when I've got a regular old structure, regular old variable, into a pointer variable, use ... what? So either ampersand or it's star. Which one is it? Regular old variable into a pointer becomes a ampersand. So what we want here is ampersand library sub I. Okay? That's going to be passing it by reference. Just like when you call scanf. I want you to go ahead and fill this variable in with whatever value you read from the standard input, ampersand. Right? And now when I compile this, it should be okay with it. Yep. Oops, there's another error somewhere. Did I misspell author last? Yes, I did. Where did I misspell author last name? Line 17. Classic. Nay. Right, there we go. Right. Don't worry about that warning. It is unused. I can go ahead and remove it, but I'm going to leave it there because it's a good demonstration of how forgets works. Okay? Excellent. Now I can go ahead and get rid of all this crap. Right? Start over. Book library is equal to, what did I call that function, by the way? Load from CSV file, right? Books.csv. All right, great. Let's go ahead and print them out, right? Print each book. For int I equals 0, I is less than, oh, wait a second. How many books are there? I plus plus. Print book. Same trick here, ampersand library sub I, because it expects a pointer to a structure. So how many books are there? Int num books is equal to, remember that it was 20, right? Is that always going to work? What if I erased one of them? What if I added more? In fact, I went into it. All this data is from Goodreads, and many years ago they had an open API, application programmer interface, that you could actually connect to it and programmatically grab at all their data. They discontinued that, but thankfully I went on Kaggle and I found 1 gigabyte of all their data. So I've got every book, Goodreads piece of data, at least from a couple of years ago, right? And unfortunately they've ended that now. But in any case, we could change, right? People are writing new books every day. So don't hard code that to 20. You tell me, how many books are there? Well, you loaded it from the CSV file. Now you're the load from CSV file function. You loaded it from the CSV file. You have to tell me how big they are, right? Just like when you loaded up all the lines from a file, you had to tell me how many lines there are, right? Just like when you filtered even numbers in lab 7 from an array of numbers, of integers, you had to tell me how big the array was. How did we do that? Through a regular old integer? Nope. An integer pointer that's being passed by reference. Num books, I should call it. There we go. Right. And where's my function? There we go. Right. Num books. Okay. Well, I can go ahead and set that right here. Num books is equal to num records. Except that, is that correct? Left-hand side is a pointer. Right-hand side is a regular old variable. How do I reconcile these two? Dereference the pointer. Right? Okay. There. Now I know how many books there are because I'm going to pass in this numbooks variable, and now I can use it. Let's go ahead and get rid of this for now, and let's go ahead and compile everything together so that, and test it. GCC wall book.o, and what do I call this? Book demo? There we go. .c. Run this, and I should have 20 books. Everything from Game of Thrones, what was it, Harry Potter? There, Harry Potter at the top. I'm sure that it works. All my refactoring of taking this piece of code and moving it over there and reorganizing stuff and updating stuff, right? I didn't break anything, okay? Now it becomes so much easier to do these 3 basic reports. What's the best book? What's the worst book? What are all the books written by Frank Herbert? Right? Why? Because I can write functions to do them now. Oops. Right. So get best book. Right. It will take a const book star library. Right. It also needs to be told how many there are, int num books. Right. And what's its return type going to be? Give me the best book. It could be book, but is that a very C style way of doing things? No. It's going to end up returning something by value. Right? Instead, I'm going to say, oh, the best book is over there. What am I doing? No, I'm pointing. Right? So let's go ahead and return a pointer to a book. Right? And let's see how that works. It's going to be very simple code. Right? All you have to do is iterate through, right? For int I equals 0, I is less than num books, right? Books, I plus plus. And if the ith book, if library sub I dot rating is greater than the best, highest rating so far, right? I'm going to come back and fix that, right? Then update the best book, right? And then, of course, return the best book, okay? Well, if your return value here is going to be a pointer, then you have best book, right? I'll go ahead and initialize it to something. I could initialize it to null. I'm going to eventually get a null pointer exception because if you start with a book with no rating, how do you compare it to any other book? So what's another better way of initializing this variable? Let's just assume that the first book that we see is the best one. Library sub of 0. Now look at the left-hand side, look at the right-hand side, and tell me. On the left-hand side, we definitely have a pointer because I see a star there. On the right-hand side, do we have a pointer there? Nope. How do I make this into a pointer? Ampersand. Great. Now, library sub I, is it dot or is it arrow here? Remember, library is a pointer, but library sub I is a regular old structure. When you have a regular old structure, is it a dot or an arrow? It's a dot. Okay? If that's greater than the best book that we found so far, best book dot rating, right? So once again, is this a regular old structure or is it a pointer to a structure? That should be obvious, right? Because we declared it as a pointer to a structure. So arrow here. Update the best book. Best book is now equal to the library sub I instead, and return the best book. There. Now before I test this, let's go ahead and write the other one. How do I get the worst book? What's the only difference going to be here? Worst. Why I'm I can't, no. Book, sorry. Book. If I say a word and I'm typing it, that word is going to end up being typed instead of just spoken, right? All right. What else? Oh, worst book. There we go. Worst book. There we go. And then worst book. All right. Anything else needs to be changed except for superficial variable names? Hopefully. What's the worst book? The one with the lowest rating. Right? DRY, don't repeat yourself. Wait a second, I see a lot of repeated code here, right? We're going to start looking at a better way of doing this, using generic programming, void pointers, and comparators. But we'll be doing that after the exam. Okay. All right, that's basically what wraps up the course. How to search and sort in programming languages properly. All right. Okay, so let's go ahead and get the best book. Best book is equal to, get best book of my library, num books. There we go. Let's print it out. Printf best book is, and the line, tab over, print book, best book. Right. And do the whole thing again for the worst book. Worst book. Library, num books, worst book is worst book. I do have to come over here and make sure that this is in my library over here. And I will come back and put in some documentation, right? I'll let you do that. Again, don't worry about any of those. The red herrings. Compile. Oops. I didn't close something. I didn't close that, and I didn't close that because of my copy pasta. There we go. All right. So the best book was Harry Potter, I think. The worst book is, also Harry Potter. It's a stupid mistake. It's not a mistake I intended. But it illustrates, again, why copy pasta is evil, right? Because I copy pasted and changed worst, except for one thing, right? And there, now it's Dianetics by L. Ron Hubbard. Right? All right, with 25 minutes left, with 24 minutes left, the last report here, right? That's going to be a little bit more complicated, but we can definitely do it in the next 20 minutes, right? So first of all, same trick as before. I'm not going to get all of Frank's books. I'm going to immediately jump to the more general get books, Frank's books, get books by author. And I'll pass in the library, the number of books, and of course an author, A. Okay? That's what I want it to look like. We might need to massage that a little bit more. So let's come over here and put it in as a prototype, first of all, because we are going to need to make changes to it. Right? And let's go ahead and start by writing it. Well, if you're going to create a brand new array that holds new books, you need to know how big that array is going to be. So I need to go through the array and find out all of the books that were written by this particular author, right? So for int I equals 0, I is less than num books, I plus plus, right? If library sub I was written by author A, then I will increment a counter, count plus plus. For that, I will need to create a counter. Int counter is equal to 0. Always initialize your variables. If I did not initialize that to 0, what value would it be? Who knows? Dead beef, garbage. Garbage plus 1 is still garbage. Right? How do I know if the ith book was written by that author? Well, we started out in Java by simply just writing out the comparisons, right? If the first name is equal to that last name, or the first name is equal to that first name is equal to that last name, right? But then we have ultimately put that into a function. And that's what I'm going to do here as well. Right? I'm going to write another function, int compare author. Right? And it takes an author star A, author star B. And I'm also not going to be making changes to this author. I'm not going to be changing its first name or last name or anything about it. So I'm going to go ahead and put a const in front of it. This is getting very, very close to what's called the comparator, and that's what we're going to look at after the next exam here. Right? What it's going to do is it returns an integer based on the following. If A comes before B with respect to last name, first name, right? So Smith and Smith, or Herbert and Herbert, Brian and Frank, Brian is his son, right? Brian would come first in alphabetical order. They share the same last name, so you look at the first name. And then if they have the same last name and the same first name, break ties some other way, right? So if A comes before, it returns an integer, something negative. If A comes before B, it returns 0 if the authors have the same name, and it returns something positive if B comes before A, right? With respect to last name, first name. Gee, that sounds really familiar. Where have we seen that pattern before? Something negative, positive, or 0, depending on the relative ordering of those two things. STR, CMP. Right? That's why STR CMP is written like that, right? Because it's a very, very common pattern. In every programming language I've ever seen, this pattern is followed, right? It's not just C or Java or anything, right? All right, let's write that first. So I've got two authors here, A and B, and I want to look at their last name. So let's go ahead and create a result here. And I'm going to use strcmp because it's already in the string library for me. A's last name, right? And I'm going to compare that to B's last name. Right? Now, if that's not 0, then that means that they don't have the same last name, right? Herbert and Butler. Butler comes first, right? So if the result is equal to 0, I need to look at their last name. Otherwise, I'll just return the result. Right? If they don't have the same last name, then we already have an order, right? Butler comes before Herbert. Right? Otherwise, if we do have the same last name, Brian and Frank Herbert, then let's go ahead and look at the first name, strcmp A first name, A first, or B first name. There we go. And now I can use this, right? I can say libraries of I dot author and compare that to A. Right? And if that's equal to 0, then I know that they have the same author, same last name and same first name. Now careful here. Is this going to compile? Libraries of I dot author and A. Those are regular old structures. This comparison function expects pointers to authors. So what do? Ampersand, ampersand. Okay. Now I know how many books are by that author. I can go ahead and set up a new setup memory. To do that, I'm just going to go ahead and create book star author books, right, is equal to a call to malloc, book star malloc. How many of them do you want? I want count. Oh, I called one count or one counter. Count. There we go. Times size of book. There we go. And that's what I'm going to return. However, does that array have all those books yet? Nope. So what do I need to do? Just like you did for get file lines, go through it once, count up the number that there are. Go through it a second time to actually, set up memory, to put them into your array so that you can return it. Right? So instead of counting now, I'm going to say that author books sub something is equal to library sub I. Right? Regular old structure on the left-hand side, regular old structure on the right-hand side, those match. I put a question mark in there because do I want to use I here? No. If there are 20 books and only 5 of them are by Frank, this one, that one, that one, that one, that one, right? I need a different index. Int j. Started out at 0. J. And what should you do if you've copied one book? J++. There we go. Excellent. Over here, let's go ahead and, oh, I don't have an author here, right? So let's go ahead and write that. Here's a really quick trick that you can use. Normally, I would go back and say, well, we've got a creator function for books. We also have an initializer function for books. We don't have that stuff for author, so repeat all my work and do that again. I'm just going to go ahead and go quick and dirty here with, I forget what the technical name for this is, but it's an initialization, right? Frank Herbert, and then his date of birth is another structure. I'm just going to go ahead and put 000 because those are 3 integers. Remember how this works? This goes back all the way to our definition here. What is an author? It's a first name, a last name, a date of birth. But a date of birth is another structure over here. Year, month, day. Okay? So there's how I can really quickly create an author, an instance of an author without having to create all those functions. Don't think that you can just use that all over the place because you can't. This is a very it's a very limited way of creating an instance of a structure. I'll say that, okay? Because I don't think that you can actually change the first name ever again, or there's some quirks to it. In any case, there we go. Once again, let's print out those books to make sure it works. Printf Frank's books. All right, for int I equals 0. I is less than number of Frank's books. Uh-oh. I've painted myself into a corner again. How many books are in that collection that I just got back from that function? I don't know. Question mark, question mark. I plus plus. Print books, not library sub I, but Frank's books sub I. So question mark, question mark. How many books are by Frank Herbert? Is there a way to tell that? Nope, I'm gonna have to redesign my function, right? Again, load from CSV file. There was no way for me to determine without the function telling me how many books it actually loaded up from the file. So we're going to have to follow the same exact pattern here that you've now seen at least a half a dozen times, right? That if you're reading lines from a file, you also have to tell the calling function how many lines that you read. If you are filtering even numbers out from an array, you also have to tell the calling function how many there were. Right? So let's come back over here and redesign this a little bit. Int num books. Num auth. Oops, this is the wrong function. There we go. Sorry, this one. Int num books. Look at that real hard though. Can I do that? Oh, by the way, I've screwed up here. Const book star and int num books. There we go. Now the color looks right. I only caught that because the color was really off, right? Black and then orange or something. Right now it looks right. Right. Can I use two variables named num books? Nope. Name the other one num author books. I like that. Bring it over here. Replace that. There we go. So, how do I tell the calling function that I have I think there are six Frank Herbert books here? Well, once you've counted them up, you have your answer, right? Num author books is equal to count. Careful. Left-hand side is a pointer. Right-hand side is a regular old variable. How do I reconcile that? Dereference. There we go. Hopefully everything's correct. First name. Oh, darn it. I'm missing the greater than sign there. That's not an arrow. There we go. Okay. Warnings, don't worry about those. And then bring that together, get books by author. What's wrong? Too few arguments. Oh, duh. Now what do? I need to pass in num Frank's books. There we go. All right, so when it's all said and done, we should finally have our 3 reports that we began with maybe a week ago or so now, right? Oops, run it, I mean. There we go. There's all the original data. There's the best book, there's the worst book, and did it work? All of those books are indeed by Frank Herbert, right? The entire Dune series, with 10 minutes to spare. Right. Any questions? No? All right, well, then let me give you an exercise to think about, not for the test, but let's go ahead and copy book demo here to demo.c. There we go. And open this file now. I'm going to get rid of everything here. Get rid of that too. All right. Write a piece of code that does a countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. How would you go about doing that? A loop, right? What kind of a loop? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You know how many iterations you're going to go, right? You're going to go 10 iterations. So maybe for int I equals n, I is greater than or equal to 1, I plus plus, or I minus minus because it's a count down, right? Printf %d end the line I. And then after it's all done, printf blast off. Okay? Right? This is like week 2 code, right? This is not a hard part, right? Let's run it. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Excellent. Now, imagine, this is the challenge that I'll leave you with without an answer. Imagine that you live in a world where you do not have for loops. Oh, well, we could do a while loop, right? Now imagine that you live in a world without while loops. Now imagine that you live in a world without loops at all, right? Do this not using any loops. And don't cheat. Don't just say, well, printf 10, printf 9, printf 8, printf 7, right? Blast off, right? It's got to be that you've got a variable here, and so your blast off could be like 100, 99, 98, dot, 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 then blast off. So it's got to have some sort of a variable. You can't just cut and paste code, but you cannot use any loops. No for loops, no while loops, no do while loops, and no for each loops or enhanced for loops in Java. How do you do it? And just in case you think that this is an artificial question, don't think that. There are programming languages where there are no loop control structures at all. They're called functional programming languages. There's a strong hint. Why are they called functional programming languages? Because their de facto way of doing stuff is functions, right? How could I do this with just a function? Okay. Do you want a hint so it doesn't, grind at you for the exam? No? Yes? Okay, recursion. Right. That's the next topic before we get into searching and sorting. Right. And we have time, so let's ask Google.com. What is recursion? Okay, ask the right question. Recursion. There we go. I must have misspelled it. Did I mean recursion? I must have misspelled it. Do I mean recursion? So what is recursion? It's self-reference, right? The definition of recursion is this is their little joke, right? Recursion.com. Drug discovery. All right, never mind. That's just some company that used that word thinking that it's cool or something like that, right? So what is recursion? It's self-reference. You've probably seen it in, say, fractals. With respect to code, it means that you can write a function that calls itself, right? So my function, my awesome function will call my awesome function. My awesome function will call my awesome function again and again and again and again over and over again until you stop the recursion. That's what we'll look at on Monday after your exam. Any questions? All of this stuff will be posted along with all these notes here. So it was kind of light on notes, and more heavy on actual demonstration code. So the code will also be posted. All right, then. Good luck on your exam and any others that you might have.